Hello, I'm Kennedy Bush, and I'll be teaching you about Earth's place in the universe, particularly the age of the Earth, and we'll be examining some evidence to support that. And I've used the textbook Earth's Evolving Systems by Ronald Martin to plan this lesson. When you've learned about the age of the solar system in the past, you may have heard that it was about 4.5 billion years old. But how do we know that? Humans weren't around back then to write it down, and we can't exactly ask the Earth her age. Geologists use evidence and tools such as radiometric dating to determine the age of the Earth. The Earth's materials have existed and been around since the Earth formed, but because of the Earth's geologic processes like erosion and plate tectonics, these rocks have changed and their geologic clock has been reset. So we can't determine the date of those materials directly. And by dating, I don't mean taking your crush out to dinner, but rather radiometric dating, which is using or measuring the decay of elements in rocks over time. An example of this is carbon dating, which you may have heard of before. And in carbon dating, carbon-14 atoms, which are unstable, decay into nitrogen-14 atoms. And in living organisms, these carbon-14 atoms are consistently replenished by the food that they eat, or in this case, carbon dioxide that this tree takes in. And so they have a constant number of carbon-14. In this case, we'll use 32. But once that tree dies, these carbon atoms begin to break down into nitrogen atoms. This happens over a set amount of time, which we call a half-life, because half of these 32 carbon-14 atoms will break down into nitrogen atoms. So after one half-life, we now have half the number of carbon atoms. Instead of 32, there's now 16. And those other 16 are now nitrogen atoms. And this can happen repeatedly. So a second half-life would get us 8 carbon atoms left and 24 nitrogen-14 atoms left. And the process can go on and on until there's no longer any carbon-14 atoms left in that organism. And carbon dating is helpful for up to 50,000 years, but objects that are older than that, we have to use different elements because these elements have longer half-lives and can even have half-lives beyond 4 billion years. So let's look at some evidence that supports that the Earth can be 4.5 billion years old. The first one is the HS-ESS gneiss, which is found in northwestern Canada. It's been dated to be about 4 billion years old, and it appears to have been part of Earth's early crust formation after the Earth cooled down. Our second piece of evidence are zircon crystals, which look something like this. This lower one was found in a sedimentary rock, and it was dated to be about 4.4 billion years old, so even a little older than that HS-ESS gneiss. Our third piece of evidence are moon rocks, which have been brought to Earth by the Apollo space missions and some Russian unmanned missions. And these specimens have been dated to be about 4.5 to 4.6 billion years, so even a little bit older than these zircon crystals. The moon's lack of plate tectonics and erosion has allowed these ancient materials to be preserved. And so we don't have to worry about their geologic clock being reset. And that's the same for our fourth piece of evidence, which are meteorites, which have come to Earth. And we have been able to date those to be about 4.5 billion years as well, which suggests that not only the Earth and the Moon, but also other parts of the solar system formed around 4.5 billion years ago. So our key takeaways from today are 1, our solar system formed about 4.5 billion years ago, including everything in it. 2, radiometric dating acts as a geologic clock to measure the age of rocks by using unstable elements and their breakdown or their decay products. And 3, moon rocks, meteorites, and ancient Earth rocks all support the claim that Earth formed about 4.5 billion years ago with the rest of the solar system. I've enjoyed teaching you about Earth science and the age of the Earth, and I look forward to teaching you again. Thank you.